As I like to tell my friends, if you are a non-technical person interested in science and space exploration, there's no better place in the world to work than perhaps the best way to introduce our next speaker without running through a very long list of accolades and accomplishments is to tell a little anecdote, perhaps a teaching moment. I'm a lawyer for NASA, and some people wonder what lawyers do at NASA. One of the more interesting aspects of the practice is to give preventive advice in advance on whether or not our civil servants can accept awards and prizes from outside organizations. Many years ago now, I had been introduced to John and had to do an analysis of whether or not we could receive a particular award or a particular institution. We looked to see if there were more standards in place, whether the award or not it's a pretty straightforward analysis. What changes, of course, are the facts from time to time. We look at the regulations in the government books. One of the examples listed in the ethics regulations applicable government-wide, which I did happen to point out to John at the time, was U.S. Department of Agriculture scientists could accept a Nobel Prize if offered. And I thought, after reading John's book, you know, it's not out of the realm of possibility. I said, John, someday we might be able to do this for you. And of course, being the humble man that he is, he explained to me those sorts of things take a long time. There's a period the Nobel Committee waits to see the impact of any discoveries to see if they're legit. Well, after Stephen Hawking called some of the results from the Kobe spacecraft the greatest scientific result of the century, one day in 2006, I came into the office. Of course, my colleagues were jumping down the hallway. And John and his colleague were shooting at Berkeley had the Nobel Prize. Wow. Cosmic microwave background radiation, which is one of the series of Nobel Prizes actually on that subject. If I could get this really common. So it's a very nice experience being in Stockholm in December. It's not really tourist season. And my friend and colleague, Ed, and I were walking down the street and we run into Stockholm. And we find out we were Americans and say, well, what brings you to Stockholm? It was very serious about the Nobel Prize. And so it was a very interesting experience. So without further ado, let me bring up my colleague and distinguished scientist, Nobel Prize winner, John Mather.
Wow.
David, thanks for that lovely introduction. Yeah, I remember seeing my ethics. Very nice, but it's not going to happen. So anyway, it did happen. Take a few seconds to set up this computer connection here. It usually works. So anyway, I'm going to concentrate, although maybe you may have heard that I was going to talk about this cosmic background radiation. That's not actually my topic. The search for planets around other stars, as well as with the new telescope that we're working on, the James Webb Space Telescope. Okay, computers tell me live. Is that good? It's not so good. Because we can get better pictures, right? Let's try that. go. Okay. So I want to talk about how we learn about our own history and about how we might learn more about it with telescopes. I'm going to start off with some basic stories that I've been hearing about the Earth. Now, these are not from my own work, obviously. I worked on the cosmic background radiation for a long time. Nobel has explained a great deal about the history of the Earth's view. So let me concentrate on something that's a little closer to home and for me was much more surprising. I've grown up knowing about the Big Bang Theory. It was already part of the war when I was a college kid. The cosmic background radiation was discovered while I was a college kid. So I thought I'd tell you about that. It's got a great story. So when we confirmed the Big Bang Theory was correct, that was a big surprise to me. And nevertheless, it turned out to be the world. What's been more surprising to me is the possibility of learning as much as we do think we know about the Earth and its own history, and then how much more we may be able to learn about how the Earth came to exist. So if I'll move on to my next chart, I'll tell you a little bit about what people think they know about the Earth. So we have an astonishingly precise measured date for the beginning of the solar system. This is the age of the earliest little bits of sand and such that we can find orbiting the sun. Either we pick them up from rocks on the moon, or we pick them up from little bits of comets that we bring home, or we find them on Earth. Anyway, we have this astonishingly precise date, 4.567 billion years ago the sun got started. And apparently the early formation of the solar system was really quite quick. It took a few million years to establish the sun and the basic direction of planets that we still have. But then a few rather remarkable things are supposed to happen, and this has been worked out by people studying the solar system. The incredible many decades was, well, how come the moon that we have is so different from the other moons in the solar system? How did we get it? And the current theory that seems most popular is that it's about the size of Mars is the Earth. So I guess that tells us about Mars and try studying it also. Anyway, the collision was rather spectacular. The story goes that everything was melted down from the surface to the bottom, and huge amounts of material came flying back out into space, being around this object, combined Earth and Moon, and from that debris, rock was formed again, turned into the Moon. So I don't know whether the theory tells us that it was formed from vapor or formed from chunks of rock that came out of the Earth. So certainly there's a huge amount to be found out by studying the Moon, so I definitely concur with Jim Garvin's point that it's a very fascinating place to go if you want to learn more about the early history of the solar system. At any rate, it seems to be that all the lightweight elements like carbon and hydrogen, which we are rather fond of here, might have just dispersed out back into space because everything was so hot. So if that's true, then the early Earth was rocky and hot, and there were no light engines. So that might mean that we had to have additional bombardment from rocks that would bring us water and carbon. There was even a theory for a long time that maybe the oil that we have underground was the result of direct deposit from space projectiles. I think that's not very popular these days, but it was at least a competing theory at one time. So then after that, then the early Earth was probably a little bit cool because the sun was not as bright as it is now, and so that might have been pretty interesting times as well. Then quite recently, the people that studied